Okay. So I'm going to have a quick look at this thing and try and see if we can figure out what's wrong with it. Which is, I'm not promising. Oh, I can't even reach the desk from here. Anyway, the setup is a bit new. So I cleaned this thing up a bit with a toothbrush and brought all the junk off of it. Let's have a look at what we have here. It's a switching power supply, like I said. Line voltage comes in on here. Ethernet goes in here, we add DC to it and it goes out. Having a look at the circuit board, I've taken a picture of the schema. I've taken a picture of the circuit board. I'll overlay that later. I don't have a print. Goes to this D1, which is a bridge rectifier. I assume it's a bridge rectifier. I don't know what else it would be. D1, it's a bridge rectifier. This going across here is this measuring. It's a capacitor, I think, for feedback. Ceramic capacitor. Oh no, that's the Z1 capacitor, which provides isolation. That provides neutral isolation. So the neutral path goes from here to here, and it goes through this capacitor, which is called a Z capacitor. This is a bit interesting because where I am, we don't have a neutral. We have two lives. We have no ground, and we have two lives, which are plus 110, minus 110. So we have 240 volts that are 230 volts at our outlets. But it's plus minus. So any outlet can be wired for 110 or 220. All the outlets in this house are wired for in this apartment are wired for 220, but there's 3 wires in each outlet, and I don't know why it's done that way. It's a quirk. I think it's weird. They don't do it that way in new buildings. Here. Bridge rectifier goes to, output of the bridge rectifier goes to there, which is transformer of some sort. Maybe that's just for isolation. I think that's just isolation because it's across. Is it 1-to-1? I'm not 100% sure how SMPSs are configured. That looks like it's just 1-to-1 isolation. Oh yeah, it is. This is an isolation transformer. Yeah, it's just a 1-to-1 ratio isolation transformer, and we can probably confirm that if we measure the resistance. Well, there's all sorts of crap on here. So if we measure the resistance of this side coil, we'll get all the circuitry as well. But we'll try it. I don't think we'll see a result. I mean, no, we're going to be measuring all sorts of junk. $221. Okay, no it's not. What's that, megs? 9 megs. What is this? These probes are terrible. 7 megs. .84. I'm saying that's a 1-to-1 isolation transformer, and the reading is lower on this side because we're measuring resistance because of this crap on here. We're getting bleed over. Anyway, there's a driver IC, and the way these things normally work is power comes on into here. Power is applied, fed through the IC, is rectified, provides DC, rectified by the rectifier, which is here, provides DC to this group of circuitry, which includes a driver IC there. The driver IC boots up. It's actually a little microprocessor usually, because it has feedback. The driver IC has a way to get started from this voltage alone, and then once it's started, once there's DC, because the DC component is just passive. The rectifier and all that stuff provides DC on these capacitors in a passive way. When there's DC, the rectifier boots up, and then it starts feeding pulse width modulated PWM electricity from these capacitors as the supply into this transformer, which has 2 windings there and there. Normally these things have 3 windings. They have an input winding, an output winding, and a very small feedback winding. And the feedback winding is fed back into there so that it calculates how much power, how wide and how close to drive the PWM cycle. Whether this has, I don't know for sure. Looking at it closely, we seem to have these 2 on the top, 2 windings here that are our outputs. Maybe that's the feedback output and that's the supply, only because it's bigger. And the inputs, those are definitely the inputs. 1, 2, 3, 4. Could be 4 inputs. We might decap this. 1, 2, 3. Either 4 inputs or either 4 input windings or 2 input windings. It would be usual to have 1 input winding and 2 output windings. And then obviously this is the mains side, and then this is the low voltage side. Because this would be, I believe, fed at, I don't know. I'll try and get a schematic of this. I'm not expert on SMPSs. I'm just doing this from memory. I have to be honest, when I was poking around this, I had a guess at what was wrong with it, and it turned out I was right on my second attempt, so I'll show you. Nothing here looks burnt. Everything looks intact. I cleaned it up with a toothbrush. So normally if something has gone, it will have exploded. There'll be a brown mark on either the item or on the back plate. And the back plate, as you can see, is clean. So, what is the problem? Usually what goes in these is the transformer windings, because they're exposed to the most voltage and they have the lines attached to them. So this outputs, and these outputs are going to be coupled to the Ethernet, which in turn are going to be coupled to they're going to be coupled to the Ethernet, they're going to be coupled to whatever is, this is where you have the potential for issues. Because if you have a long Ethernet cable plugged into here, then that could pick up a if that's running alongside a mains voltage line, there's a spike in the mains voltage line, it'll transfer into here, and it could backfeed and blow the transformer up. And the transformer windings are hair-fine windings. They're very, very small. So let's have a look. And we'll just measure the windings. And as I said, I've done this before, so I already know what the issue is here. Where are the transformer windings? Well, we have 2 coming out here, 2 coming out here. And the 2 that are coming out here are this and this one, which are wires, and these ones, which are, again, wires. So we'll measure them. And that reminds me, I have to clean up my meter probes because they're filthy. Resistance of this winding, 1.2 ohms. It's about right for a transformer winding. You don't want a lot of resistance. Resistance of this winding. It's open loop. OL. OL supreme. Check again. Nope. So that's the answer. That's the answer. This winding and we can prove that, I think, by cutting these wires and just testing them separately. Because this is not something I was going to fix. We'll get that one. And we'll get that one. Eventually. We'll strip a bit of copper out of it. Oh wow. There's not a lot of wire in here, so I'm reluctant to. Okay, there's some copper. There's some copper. Okay, on the 1, on the 2, I hope you can see this. Are we in focus? Yes, we are. Okay, connectivity. 1, 2. Doesn't like it. We'll just make sure I'm not screwing it up. We'll put them on this plastic and we'll press really hard. One. Two. Oops. That's it. That's the answer. There's no voltage here. There's no continuity here. This winding has blown up. And that's why this thing is not working. And it's not worth fixing. So I'm going to buy another one.